This is Geometry Lesson 2.5, Proving Angles Are Congruent. The I-CAN statement for this lesson is student will be able to prove and apply theorems in geometry. Vocabulary includes the term postulate. This is one we had before, so remember that a postulate is an accepted statement of fact. And therefore, you do not need to prove a postulate. As opposed to a theorem is a statement that has been proven. All of you should have and will easily remember a very common theorem called the Pythagorean theorem. There are many other theorems that you've had and that we'll have during this year, but that one is the most famous one, and that one had to be proved at some point. A given is what you know from the hypothesis of a theorem. You don't have to prove a given because basically it is given to you. The given part of a theorem usually entails maybe a drawing or a diagram or some idea that leads to a conclusion of the theorem. Our example that we're going to do first is a algebra proof. If we're given this equation, 3x minus 8 equals 4x minus 11, and someone says, well, prove that x equals 11 in this case, we can approach this by doing a proof. The first statement in our proof will be that 3x minus 8 equals 4x minus 11. That is the given. So the reason we know that this is true is because it was given to us. That may appear pretty obvious, but that's what we're going to use for our given, even though it's very obvious it was given to us. Most of you already recognize to solve this, we need to subtract the 3x from both sides, and that'll result with negative 8 equals x minus 11. The reason we know that that is still an equality or a true statement is because of the subtraction property of equality. The next thing we would do is add 11 to both sides, and the result would be 3 equals x. We know that 3 equals x because we applied the addition property of equality by adding 11 to both sides. We're still not matching exactly what we wanted to prove, but it's a simple step of switching those around. And the reason we can switch the 3 and the x is because the symmetric property of equality says that if 3 equals x, x equals 3. And now we are done. You'll see that what we were asked to prove is the very last line. What we started out with, the given, is the first line. And this is applying that idea of the law of detachment and the law of syllogism, so that you can see we start with this, and through each one of these steps work our way down to the final conclusion of x equals 3. We have talked about a term called vertical angles before, and let's go over those again. Vertical angles are a pair of opposite angles that are made by intersecting lines. And you can see in this diagram over here that we have a pair of vertical angles. 1 and 3 are vertical angles, and also 2 and 4 are both vertical angles. From the vertical angle definition, there is a theorem that states that vertical angles are congruent. Always, when you have vertical angles, they'll be congruent. It has been proven through this theorem called the vertical angle theorem that vertical angles will be congruent. In our example here, 1 and 3 would be congruent, and 2 and 4 would be congruent. We can actually prove that theorem in the following steps. So first of all, we'll start out with what is given to us. We're given that we have an angle 1 and an angle 3 that are vertical angles. From here, we're going to work our way all the way down to proving this. We're proving this theorem. Okay? So we can't rely on this theorem to prove the theorem. We're going to work through some steps to get that. So since they are vertical angles, we can look at this diagram over here, and you'll see in our diagram that angle 1 and angle 2, if we look at those, they're forming a straight angle here. So by the angle addition postulate, we know that angle 1 plus angle 2 must equal the angle that they create, which happens to be a straight angle. Next, looking at that diagram, you'll also see there's another straight angle. This angle that's created by 3 and 2 is a straight angle. So again, by the angle addition postulate, we can make this statement: the measure of angle 1 plus the measure of angle 3 equals 180 degrees. The next step in our proof is using either the transitive property or substitution. I have listed here substitution, or some of you may recognize that we have something equal to 180 and something else equal to 180. So we can skip the middleman. Remember, that's what kind of happens with the transitive property, and set the first one equal to the third one. Or we can just say, if we know that 180 is this thing, everywhere we see 180, we'll substitute what it equals. So that's why I've listed it as the substitution, or the reason we can do this is by the substitution property, by saying, okay, we'll take out that 180 and substitute what it equals, which gives us this equation: the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. From here, we're going to subtract whatever that measure of angle 2 is from both sides. They both have to be the same, so when we subtract them, we're left with the measure of angle 1 equals the measure of angle 3. That was the subtraction property. Properties. Should have a T in there, sorry about that. We're almost there. What we are asked to prove is this. It looks pretty close to that. This is an equation. What we're asked to do is show that we have one geometric figure congruent to another one. Angle 1 is congruent to angle 3. This just says that their measures are equal to each other. But wait a second here. Isn't that what congruence actually means? Congruence, by definition, is when two angles measure the same. By definition of congruence, we can just say, hey, we've got the same measure, therefore these two are going to be congruent, and we have proved what we set out to prove. We have proven this thing up here, the vertical angle theorem. Once it's proved, using this, there will not be a counterexample. We can always accept it as a proven fact after we have set up and proved it. I want to reiterate some things that I pointed out up above and again here. Notice the first line of the proof is the given. Right here. We even state it as the reason we know it's true. This matches what we are given. The very last line matches exactly what we were asked to prove. We were asked to prove that we have those two congruent, and we did it. We didn't even stop here when we said, oh, well, their measures are the same. We have to match this exactly. This thing that you have right there is a full-fledged two-column proof. We call it a two-column proof because it contains two things. Two columns, as we've set them out. One column over here are all the statements. By statements, what we're talking about is the sequential list of facts that lead to a final conclusion. Sorry, I show this again. I think I was off a little bit here. Let me go back. Again, first line is what we are given. Last line was what was to be proved. And this is called a two-column proof. The reason it's called a two-column proof is because it has two things in it, all set up in two columns. All of these are statements. You don't see any reasons over here. You see things that apply directly to this problem, this set of diagrams, this set of conditions. We start with what's given, and we go all the way to the final conclusion. This is always going to be on the left-hand side. You'll never see a statement over here on this side. On the right-hand side, we have all of the reasons. This is a sequential list of reasons for each corresponding step. We did that yesterday. You did it up above in the algebraic proof. It's basically saying, why do we know that this thing is still equal to? Why do we know that the next thing may be congruent? These will always appear in the right column. Statements, reasons, two-column proof. Let's do another one. First of all, let's introduce some other terms that we're familiar with. Supplementary angles. You remember, supplementary angles are a pair of angles whose measure is 180 degrees. We have another theorem called the congruent supplement theorem. It states that if two angles are supplementary to the same angle, then the two angles are congruent. Let's prove that from this diagram over here. Again, let me just describe what it's saying. It's saying two angles are supplementary to are supplements to the same angle. In this case, you can kind of see that if we put 1 and 2 together, we'd end up with 180 degrees. So 2 is a supplement of 1. And then if we were able to drag 3 over here, you can see that, again, we'd form a straight angle between those. We'd form a 180 degree angle. So 3 is also congruent to angle 2. By this theorem, we don't have to check the measures of both of these. We know for sure that angle 1 will be congruent to angle 3. Let's do a quick proof of this. So first of all, we're going to start with that statement. The statement is what is given to us, and we're given two things. We're given that angle 1 and angle 2 are supplements, and we're given that angle 3 and angle 2 are supplements. This is written here as one line. You could write it as 2 lines. There's probably good reason to show this as given number 1 and given number 2. Or, as I've done here, they're just grouped together as the given. But typically you want to show one line for each reason. Now what are we going to do with that? Well, look at what happened here. We have been given just a statement. 1 and 2 are supplements. But we know the definition of supplement, up here, which we reviewed, says that supplementary angles sum is 180. So we've taken this term and used its definition to write an equation. Remember back when we first introduced this idea of deductive reasoning. Deductive reasoning used facts, a fact such as something that's given to us, or a postulate, and also definitions. By this term being given to us, we use its definition to get to this first line. Also, you'll notice in our given, we know that angle 2 and angle 3 are supplements. So by the same reason, we can write another equation that says the measure of angle 3 plus the measure of angle 2 equals 180 degrees. And this is looking very similar to the last one we did, because the same reason, I won't go over this again, but it's either the transitive property or taking this 180 and substituting in what it is equal to and replacing 180 with the measure of angle 2 plus the measure of angle 3 gives us this equation. And the rest is exactly like we did before. We subtract the measure of angle 2 from both sides. Once we've subtracted the measure of angle 2 from both sides and listed that as the reason, and that typo just keeps appearing and appearing, that should be subtraction, property of equality. Same thing we did last time. We're not done yet. We need to show that these two are congruent, not that their measures are the same, but that's a simple little step. By using the definition of congruence, we know that angle 1 is congruent to angle 3. And we're done. They match. We worked all the way down to the end. So our second theorem of today, with only a few steps, we were able to prove it without a shadow of doubt. There's no one that can challenge us on that. It has been proven. You won't find a counterexample for that because we've used proper logic, the deductive reasoning, to get to that conclusion. A two-column proof is not the only kind of proof there is. A proof's purpose is just to communicate clearly in a convincing way your argument. We've talked about this before, that what we're doing is the exact same thing that happens in a courtroom. People present a case, they present facts and definitions and things that lead to a final conclusion. But they don't go into a courtroom with two columns and present the facts and give their reason, present the next fact and tie them all together. There's other ways of presenting those facts. And sometimes it might be easier, rather than do it like this, to actually write some sentences. This can be done by way of a paragraph proof. Let's take a look at this. We can write a paragraph proof for the congruent supplement theorem, what was up above. And I've written it all out here for you. And before you start writing, let me just read it through, and then I'll give you some time to write this down. And this is a paragraph proof. So we're just basically kind of walking our way through this and just talking it out, writing it in sentence form. So first of all, by definition of supplementary angles, measure of angle 1 plus the measure of angle 2 equals 180, and the measure of angle 3 and the measure of angle 2 equals 180. What we did up here, but it's just in common English terms. Then, by substitution, we end up with this equation. Subtracting the measure of angle 2 from each side, you get the measure of angle 1 equals the measure of angle 3, or the angle 1 is congruent to angle 3, which would be the way you would describe what we did up here. You can see sometimes you can be a little bit more concise on this. The reasons may or may not be given for each one, but you're talking someone through how you got from the given that there were a pair of supplementary angles, supplementary to the same thing, to the final conclusion of angle 1 being congruent to angle 3. So I'll give you a few minutes to write this down as your first paragraph proof. By the definition of supplementary angles, measure of angle 1 plus the measure of angle 2 equals 180. And the measure of angle 3 plus the measure of angle 2 equals 180. By substitution, we're setting both of these equal to each other by substituting in what 180 is. We get this equation. Measure of angle 1 plus the measure of angle 2 equals measure of angle 3 plus the measure of angle 2. The next thing we would do with this is stated in the next sentence. Subtract the measure of angle 2 from each side. Finally, you get the measure of angle 1 equals the measure of angle 3, which we know is the same thing as saying those two are congruent since they measure the same. There's another important theorem, and that's the congruent complements theorem. Basically the same thing up above that we did with supplement. We won't prove this one, but it says if two angles are complementary to the same angle, B is complementary to A, B is complementary to C, then these two guys here, angle A and C, are congruent. And In this case, again, angle A would be congruent to angle C by this congruence complement theorem. The next couple theorems kind of make sense to most of you. So even though they are theorems, you might say, I shouldn't have to prove that. They just make sense to me. All right angles are congruent. We could prove that real simply because every right angle's measure is 90 degrees. So by definition, they must all be congruent. Next theorem in our book is labeled as 2-5, and it states this. If two angles are congruent and supplementary, then each of them has to be a 90-degree angle. Think about that. If both of them add together and they equal 180, and they are congruent, well, there's only two values that could be if for both of them be the exact same value, and that would be 90 and 90. And by definition, if an angle is 90 degrees, it's a right angle. So we have covered four theorems in this unit, and two of them we went ahead and proved. The last set of problems that we're going to do use those theorems, so we don't have to go back and prove them. We're just going to use them here. The first one's using the vertical angle theorem. Because these two angles are vertical, we know that they are going to be congruent to each other. Since they're congruent to each other, their measures are going to have to be equal to each other, which allows us to solve for x here. A little bit of algebra, subtract the 2x from both sides, and as a matter of fact, we could even add 40 to both sides at the same time. This would leave us with x equals 30. If it asks us to find the measure of the angle, we would substitute in, but in this case, it's just saying find x. The next one is just a definition of supplementary angles here. Both of these together form a 180-degree angle, so therefore, we're not going to set these equal to each other. There's nothing in here that's telling us that these two are equal to each other. But from the diagram, we know that their sum is going to be 180 degrees, which would mean 6y minus 10 plus the 6y plus 10 equals 180 degrees. Add those together. This would be 12y, negative 10 and 10 give us 0, equals 180 degrees. And then from there, we would divide both sides by 12. And once we divide both sides by 12, we would get y equals 15. And again, it didn't ask us to find the measure of the angles, it just asked us to find the value of the variable. Let's take a look at number 3. These two are going to sum to 90 degrees. If this is a straight angle, and this is 90 degrees here, then we're left with the 90 on the other side. For z minus 10 plus another z would give us 90 degrees. Simplify 5z minus 10 equals 90. Add 10 to both sides. 5z equals 100. Dividing both sides by 5 would leave us with z equals 20. And we're done. Next one, similar to that. Please notice, these two are not equal to each other. I'm not going to set these equal to each other. There's nothing in here that tells us that they are equal to each other. Okay? So, 90 here, their sum is going to be 90. So we'll start with 9x plus 4 plus the second angle, 32, will equal 90 degrees. Combine some like terms, 9x plus 36 equals 90. Subtract the 36 from both sides. This will leave us 9x equals 54. Divide both sides by 9, and x equals 6. next one. We have some options here to solve for x. We have one option is vertical angles here. We could say that 4x plus 1 equals 65. We also have the option here of adding these two together. Since they are supplements, when we add them together, we would get 180 degrees. Neither one is more right than the other. I think most of us would agree. More terms here, fewer terms there. We'd probably want to say, let's just get this one. So you can see this one isn't so bad. We would subtract 1 from both sides. This would give us 4x equals 64. Once we divide both sides by 4, x equals 28. Oops, sorry, 26. X equals 26. The next one. Well, this angle here, if you didn't notice, has to be 90 degrees. Reason is, it's vertical to this 90 degrees. There's other ways you could have gotten to that, but definitely we have a pair of vertical angles. So with that being 90 degrees, we know that the two parts of it, 4y and 6y, their sum is going to be 90. Simplify, combining our like terms. Divide both sides by 10, y equals 9, and now you're done. So that is your notes for 2-5. I hope you've enjoyed these, and now go ahead and go to Schoology, and you will work on your homework for 2-5 and a few other activities that your teacher will have for you. Have a good day.